There are different methods of integration. I think for your syllabus, you have only two methods. One is integration by substitution, and the next one is yeah, by parts. Partial fraction also you have. Yeah, partial fractions you have. So these are the three methods that you'll be going to learn. One is the substitution method, another one is the partial fraction method, another one will be integration by parts. Okay, so we'll move on to, so as I told you, there are three methods. The first one is integration by the method of substitution. The second one is integration by the method of partial fractions, and the third one is integration by parts. These are the three methods. Integration by substitution. The name itself indicates that you are substituting a certain value, all right, to get the required solution. So, however, theory will not be explained. If you take an example, only then you can understand what exactly that we are substituting and what exactly we are getting the solution. So, we'll take an example and see how exactly this substitution method works, right? So, we'll straight away move on to exercise 7.2. Exercise 7.2. So, the first example that you have 2x by 1 plus x square. That's the question you have. 2x by 1 plus x square. Let us try to integrate this one. It is the integral of 2x by 1 plus x square into dx. Whenever you go for the substitution method, in the substitution method, you always be having a function. Along with that, you will be having its derivative. Now, this derivative can be in the numerator, can be in the denominator, depends. Various ways are there. I'm just showing you one way where if it is in the numerator, then what has to be done. All right. The integral will always be in this form. Whenever you are going for the substitution method, the general form will be f of x into f dash of x into dx. So the method that you have to follow is that you have to put the value of this f of x. You have to put this, that means you have to substitute this by some variable, say t or u or v, whatever variable. I am using the variable as t. So we'll take the same variable. So if you're taking f of x to be equals to t, then if you try to differentiate this one, you have to get back that f dash of x value. So if I try to differentiate this one, differentiation of f of x will be f dash of x, right, into dx. That will be equals to differentiation of t will be dt. But actually, because you're differentiating with respect to x, the actual way that you follow is you write down this value as dt by dx. Differentiate with respect to x, you get dt by dx. But what we'll try to do is we'll just cross multiply this dx on the other side and write it as f dash of x cross multiply this dx is equals to dt. Are you getting this one? But while solving the problems, we don't use this step. After this, directly we'll move on to this step. So make a habit of writing this directly. Usually, it is written directly in this form. But the actual way is you're differentiating with respect to x. Differentiation of f of x will be f dash of x, and differentiation of t with respect to x will be dt by dx. Further, you cross multiply dx on the other side, you get f dash of x into dx to be equals to dt, right? So if we try to observe over here, now the question is direct integration is not possible because it is not in the standard form. But you can see that the numerator is the differentiation of the denominator in this form, integral of f dash of x by f of x into dx form. It is in this form. One of the form I have shown here, the other form is over here. If you try to differentiate this denominator, you get the numerator. That is what you can see here. 1 plus x square. What is the differentiation of 1 plus x square? 2x. So that is there in the numerator. Therefore, you can go ahead and use the substitution method. Are getting it? So substitution method has to be used whenever you have a function and its derivative, or maybe in the denominator wherever it is. So let us put over here 1 plus x square is equals to t. Now let us try to differentiate. Now what I have told you, we'll try to write down this step directly. Are you comfortable writing this step directly? So if you try to differentiate this one, so derivative of 1, the constant is 0. Differentiation of x square will be 2x into x differentiation will be dx, and differentiation of the t will be, that is there in the numerator, 2x dx. Let me take the integral to be I. So therefore, the integral I will be equals to integral of 2x dx can be replaced by dt divided by denominator 1 plus x square. So 1 plus x square can be replaced by t. So it is integral of dx by x form, or you can say that it is integral of 1 by x into dx. 1 by x into dx is nothing but log of x. So therefore here also you can write down its value will be equals to log of t, right? 1 by t dt it is. So therefore you can write that value to be log of t. So if you want, you can write down more. That is always there, is understood. But if you are having a habit of writing always moderately, you can write down, no problem. This will be log of, what is t value? 1 plus x square. So we'll be getting mod of 1 plus x square. Plus this constant of integration will be c. So you start with x value, in between you use t. Again, finally substitute t and express in the form of x. This will be the required solution. Getting it? Any questions here? On to the next one. Log of x whole square. Log of x whole square divided by, it is x. So we'll try to integrate it. Let us take the integral to be I is equals to it is integral of log of x whole square, integral of log of x whole square divided by x into dx. It is. What should be the substitution over here? Log x, because 1 by x is present there. Therefore, you can take log of x to be equals to t, because if you differentiate, you have to get back that value, 1 by x. Log x is t, therefore we'll try to differentiate this one. So differentiation of log will be 1 by x, and differentiation of x will be dx. I'm just trying to differentiate this one. So that will be equals to differentiation of t will be dt. Now you plug in this value back over here in the given integral. You will be getting the value as I is equals to, it is integral of log of x will be t. So because it is t square there, we are getting that as t square, and 1 by x dx. You can see 1 by x dx. Here 1 by x into dx can be replaced as what? Dt. Now this is nothing but your general formula, x power of n into dx, which is nothing but x power of n plus 1 by n plus 1 plus the constant c. So if you use this formula over here, what will be t square value? Yes, t cube by 3 plus the constant of integration c. Now we can replace the value of t there. T value that we have taken is log x. So therefore we'll be getting log of x whole cube, right, divided by what we have, divided by 3 plus the constant of integration c. That will be the required solution. Next question, what we have 1 by x plus x into log of x. Now what is the differentiation here, and what is the value that you have? Which value you have to take as t? But here 1 plus log x is not there. You just try to integrate it, apply the integral. Let us take I is equals. So what you have, it is 1 by, I'll just try to rewrite it. So what is common here? X common, right? 1 plus log of x is taking x common times of what? Times of dx. Now if you try to observe over here, 1 plus log x should be what? 1 plus log x will be what? So let us take the value. Let 1 plus log of x will be what? Will be equals to t. That is a substitution. because we know its differentiation of log will be 1 by x is already there. Therefore, if we try to differentiate this one, where if the constant is 0, then differentiation of log of x into derivative of x will be dx is equals to dt. You can find that one. So you will be getting the value as I is equals to, it is just integral of, so 1 by x into dx, its value is dt there, divided by this denominator 1 plus log x is what? 1 plus log x is t. Is it not dx by x form? Already written it here. Is a formula, log. So therefore you'll be getting log of mod t. You have log of c. But we know the value of t over here. T value is, which is nothing but, it is log of, mod value will be plus the constant of integration c. That will be the required solution. Getting it? Next question. So given what? Sin x into sine of cos x. Sin x into sine of cos x. So you can see that this value here, sine of cos x. Suppose if I am taking this value, cos x to be some t, then its differentiation will be what? Right? Minus of sine. So therefore, let us rewrite this one. We try to integrate it. So let us say I is equals to, it is integral of. Now, whenever you have, most of the time, whenever you have composite functions, no, the value which is there in the composite function itself will be taken as t value, because its derivative will be present outside most of the times. So you have sine of x here, sine of x into, it is sine of cos of x, sine of cos of x into what? Into dx. Put the value of cos x to be t, cos x is t. Then let us try to differentiate this one. Differentiate, so its derivative will be minus sine of x into dx is equals to what? Is equals to dt. But this minus sign is not there. Therefore, the best way is shift it on the other side or just multiply by minus 1 on both sides, right? Because you don't require that minus. So the best way is just multiply by minus 1 on both the sides. So what this becomes, minus of minus will become plus. So we'll be getting sine of x into dx. And because we are multiplying by minus over here, we'll be getting minus of dt. Now you can plug in this value back there in the given integral. Therefore, I is equals to, you have integral of, first I'll write this composite function. It is sine of cos x. Cos x is t, sine t it becomes. Then this sine x, right? This sine x along with the dx. So sine x dx value will be what? It is minus of dt. But however, minus sign you can just take outside and rewrite this as integral of sine of t into dt, which will be nothing but minus as it is. Let us try to integrate sine. So what is integration of sine? Minus cos. So we'll be getting minus cos of t plus the constant of integration c. However, that minus of minus will become plus, and you'll be getting the value as cos t plus the constant of integration c. But you can even replace the value of cos t. What was t value that you have taken? T value we have taken it as cos x. So therefore, we'll be getting cos of cos x, cos of cos x plus c. Getting it? That will be the solution. We will try the same way. Sine of ax plus b and cos of ax plus b, which will be taken as t, and which will be the derivative. Here, so the beauty of this problem is that you can take this value also as t and solve the problem. You can take this value as t and solve the problem. That's the beauty of this problem. Both the ways you can do it. So it is your choice, because sine, differentiation of sine, you get that value cos, and differentiation of cos will be what? Minus of sine. But if you doesn't want to use minus sign, then you can go ahead with only sine itself. If you want to avoid a negative sign, you can take this value to be t. You can solve it in both the ways. We try that one. So this, the next question is what? Root of ax plus b. Now here you don't have one as a differentiation of the other. So in this case, because we are having square root, we know the differentiation of the square root value d by dx of root x, right? Which is nothing but
x.
2 root of x. So using that process over here, inside the root, whatever value is there, I'll take that value to be equals to t. A slightly different problem. So let me take this as I is equals to, it is integral of, it is root of ax plus b, root of ax plus b into dx. So now what I'll try to do is put the value of this ax plus b. Ax plus b will be equals to t. Right? But how can I take ax plus b as t? Because I've explained here, no? Whenever you want to use a substitution method, you should always have one function and its derivative should be present, either in the numerator or in the denominator, whatever it is. Here, the question is this derivative present here? The derivative of this ax plus b, is it present here? That's the question. What do you think? Is it present? If you try to differentiate, you have to only differentiate x, that's all. You write x in all the process what you have done, wherever you have made the substitution, you have differentiated cos as minus x into differentiation of x, you write it as dx in this case, right? Here, when I try to differentiate this x, you'll just be getting a into dx, right? There or not here. So this is in the form, but actually this problem is in this form. It is integral of root of f of x into f dash of x into dx. Whatever form it can be. But can you see, function is there and its derivative is present. This whole is given as only dx in this problem. So now if you try to differentiate this one, it is a into, now derivative of x will be dx plus b, the constant will be 0. So what is equals to dt. So a into dx is equals to dt, or dx, I want only dx because dx is there over here. Just cross multiply, we'll be getting dt by a. Right? So now if you put back this value over here in the given integral, you'll be getting I is equals to, it is integral of root of ax plus b is what? T. Dx is what? Dt by a. Right? Or I can take that 1 by a, because a is in the denominator, 1 by a is a constant right outside. Root can be expressed as power half. Root always represents power half into dt. Now we know this integral, it is integral of x power of n into dx. You know the formula, it is x power of n plus 1 by n plus 1, the constant of integration c. Using that formula, you'll be getting 1 by a t power of n plus 1 will be what? Half plus 1 by half 1 plus the constant of integration c. So what will be getting half plus 1? 3 by 2. So t power of 3 by 2 whole divided by 3 by 2 plus the constant of integration c. 3 by 2, if I get that in the numerator, between 2 by 3, 2 by 3. And this a is there, just write down that a value there. And this is t power of, can I replace this value of t? So what is the value of t you have taken? So it becomes ax plus b. It is ax plus b to the power of 3 by 2 plus the constant of integrations. That will be the required solution. So now you can go back, you complete this problem along with I think 7, 8, 7 and 8. These two problems are also same. 4x plus 2 into, it is root of x square plus x plus. Now the question is, what is the substitution that we have to make for this one? Let us write I is equals to this integral of 4x plus 2. It is root of x square plus x plus 1 times of, you get times of dx. Therefore, you're writing the value of x square plus x plus 1 to be equals to t, right? Let us try to differentiate this one. If you try to differentiate, we'll be getting 2x. Differentiation of x square is what? 2x plus differentiation of x will be 1. 1 is a constant, it is 0, is equals to differentiation of t with respect to x will be dt by dx. Or cross multiply that one, you'll be getting 2x plus 1 Cross multiply, we will be getting dx is equals to what you get is equals to dt. But this value is not there in the given integral here. Therefore, I'll try to rewrite this. Therefore, I will be equals to, it is integral of, can I take 2 common from here? 2 common, there is one way of doing it. The other way of doing is, if you want to get that 4 here itself, you can multiply throughout by 2. Two ways in which you can do it. If you want to get here itself, the method is multiply by 2. Because I want to get 4, no? How can you get 4? Multiplying this by 2. So if you want to get here itself, you can do that. That is also possible. So if you multiply by 2, you'll be getting 2 times of, it is 2x plus 1 times of dx is equals to what? Is equals to dt. Or multiply this 2 inside, 2 times of 2 will be 4, 4x plus 2 times of 1 will be 2 times of what? Times of dx is equals to what? dt. 4x plus 2 times of dx. Its value is what? dt. Now you can just plug in this value back there in the given integral. Therefore, you get I to be equals to, it is integral of root x square plus x plus 1, I have taken it as t. And this 4x plus 2 into dx, I'll write at the end. Its value is what? Its value is dt. We already done this root of t into dt here. Root of t into dt by taking t power of half. That we'll try to follow here. So if you try to rewrite this one, it is integral t power of root means power of half times of dt. Or once again using x power of n formula, x power of n plus 1 by n plus 1. So t power of half plus 1 by half plus 1 plus the constant of integration c. But t power of half plus 1 is nothing but t power of 3 by 2 plus the constant c. And you just plug in the value of t value is x square plus x plus 1. And if you take this 3 by 2 in the numerator, it becomes 2 by 3 into x square plus x plus 1 to the power of 3 by 2 plus the constant of integration c. That will be the required solution. Are you getting this? Any questions here? Move on to the next question. 10th question, right? It is 1 by x minus root of x minus root of x. That's all. 1 by x minus root of x. So let us apply the integral for this one. I is equals to, it is integral of 1 by x minus root of x into dx. But here explicitly you don't have that value where if you differentiate one value, you'll be getting the other value. That is not there. So I have to get in the standard form. So to get in the standard form, you have to take something common from here. That is the only possibility you have. So if you want to take something common from here, can I write this x as root x into root x or root x whole square? Any way you write it. X can root of x, so that I can take root x common outside, right, into dx. So now I'll take root x common here. It is integral of 1 by root of x is common. So if root x is common, you'll be left out with root of x minus, because root x is already common there, you'll be left out with 1 times of what? Times of dx. Are you getting this step? Any doubt in this step? You have to get an idea that I have to express that x in the form of root x into root x. But most of the students don't get this, idea of expressing x as root x into root x. What they'll do, they'll stop here only. That is the reason why integration, they feel it is difficult. Very simple, but you have to get an idea. Because root comes, whenever root comes, the differentiation of root is 1 by 2 root. Differentiation of this root. So that is the reason, again, we are expressing this x in the form of root only. Now you can make the substitution. This will be a substitution, root x minus 1. So put the value of root x minus of 1 to be equals to t. So we'll try to differentiate this one. We differentiate, root x will be 1 by 2 root of x, right? And 1 derivative will be 0. Differentiation of t will be dt by dx. I can write this as 1 by root x. Cross multiply the dx on this side. is equals to, but because 2 is not over here, I'll cross multiply 2 on the other side, it becomes 2 times of dt. Can you see you have 1 by root x into dx? Now you can plug in this value there. Therefore, you get I is equals to, it is integral of 1 by root x into dx, I got it is 2 times of dt divided by root x minus of 1, I have taken it as t. Or if I take 2 common outside, we'll just be getting integral of dt by t. Integral of dt by t. That is nothing but it is 2 times of integral of dt by t will be log t plus or log of mod t plus the constant of integration c. Or you can write 2 log of what is the value of t that we have taken? Root x minus of 1 mod plus the constant c. That will be the required solution. Suppose if the question was 1 by root of x plus 4, you can adopt the procedure that we are showing. So this I'll leave it as homework for you. 1 by root of x plus 4, you try to integrate and get the answer. This is very easy. Directly you can do it. Just take x plus 4 as t. And if you're writing it as integral, you'll be getting integral of dx. This you can do it, right? But this problem is slightly different one. Question number 11, right? So here x is there. X by, we have root of x plus 1. So if you differentiate this one, x plus 4, its derivative should be what? Dx should be there, no? Then only x is there, dx should be there. If x square is there, then you can have 2x there. But x square is not here. X you have, no? In that case, the same value you have to get in the numerator. 4 is there, no? Try to get x plus 4 in the numerator. So what you have to do is, before I go for simplification, I'll try to add and subtract 4 in the numerator. I have to add and subtract 4 in the numerator because I have to get the same value, no, in the numerator as well as in the denominator. Therefore, if I try to rewrite this one, we will be getting the expression as what? X plus 4 minus 4, add 4, subtract 4 divided by, we'll be getting root of x plus 4. Now we'll just try to separate this value. X plus 4, split it, x plus 4 we divide by root of x plus 4 minus again 4 by root of x plus 4. Or further, if I try to simplify this one, it is x plus 4. I hope you are comfortable writing directly. X plus 4. This is root in the denominator. When root comes in the numerator, minus 1 by 2. Minus this value will be 4 by root of x plus 4. So what I have done here, reduce that example in this form. Now 4 is a constant, you can remove outside and you can integrate it. Now let me apply the integral. Or let me write one more step. X plus 4. Now this is power 1, right? So 1 minus of half will be getting. This is 1 minus of half. Minus, it is 4 by root of x plus 4. Or this is nothing but x plus 4 to the power of 1 minus half is half minus 4 by a root of x plus 4. Let us apply the integral over here. Therefore, we'll be getting I is equals to, it is integral of x plus 4 to the power of 1 by 4 minus 4 by root of x plus 4 times of what? Times of dx. Let us try to apply integral individually for each of the terms. For the first term, we'll be having integral of x plus 4 to the power of half times of dx. Minus 4 is a constant, I'll take outside. It is integral of 1 by root of x plus 4 times of dx. Now you can use the substitution in both the cases, in the first one as well as in the second one. So put in the first case, or if you want, you can do it directly also or separately also. In the first case, first term, I'll write down In the first term, I'll put x plus 4 as what? X plus 4 will be t. I think even in the second term also same thing. First and second, the terms are not different. First and second term. X plus 4 times of x plus 4 is equals to t. Let us try to differentiate this one. So differentiation of this x is 1 plus the constant 4 will be 0. That will be equals to how much? Dt by dx. Right? Because 0 you can just ignore and just cross multiply this 1 into dx will be dx is equals to dt. Are you getting this one? Now if we try to plug in this value back here in the given integral, we'll be having I is equals to integral of, it is t power of half times of dx. Dx is what? Dx is dt. Minus 4 times of, you have integral of 1 by root of x plus 4 is t. And dx. Dx is what? Dx will be dt. Again, using the basic formula, you'll be getting t power of half will be t power of half plus 1 divided by half plus 1. Minus 4 is a constant and root represents t power of half. T power of half when it comes in the numerator, what it becomes? T power of minus of half into dt. So this is nothing but t power of 3 by 2 divided by 3 by 2 minus 4 times of. This is nothing but t power of minus half. So t power of minus half plus 1 divided by minus half plus 1. Once again using the standard formula plus the constant of integration c. Or if you try to simplify, 3 by 2 can be written as 2 by 3 t power of 3 by 2 minus 4 into t power of 1 minus half, or half plus 1 will be half. Half divided by half plus the constant c. Or this can be rewritten in the form of 2 by 3 is t power of 3 by 2 minus 1 by 2 when it goes in the numerator becomes 2. 2 times of 4 will be 8. 8 power of 8 t power of half plus the constant c. But what is the value of t we have taken in this example? X plus 4, am I right? T value is x plus 4. So therefore you have x plus 4 to the power of 3 by 2 minus you have 8 into x plus 4 to the power of 1 by 2 plus the constant c. That will be the required solution. X cube minus 1 to the power of 1 by 3 into x power of 5. I'm taking from your textbook only. X square by, what is it? 2 plus 3x square, 2 plus 3x square to the power of to the power of 3. You try these two. A similar example just now we have solved. No? X plus 2 divided by a root of x plus 6. Can you tell me how will you do this one? You see this example. Because you had, can you see here? In this example, because you had x plus 4 is there over here, therefore you brought plus 4 there. Now here you try to see what you have in the denominator, 6. What you have to get in the numerator? X plus 6 you have to get, no? What has to be added and subtracted? 6 only. Yes, it is correct. Add 6 and subtract 6. Don't be confused with this plus 2. Plus 2 will remain as it is. I have kept this value as it is, right? I've just added 6, subtracted 6. That's all. This x plus 2 have not changed. Now I'll group this x plus 6 as it is. Minus 6 plus 2 will be what? Minus 4. And divided by this will remain the same. Now it is similar to this problem. Can you do it now? We have split it now. But the question is this. This question is written in this form. I've just shown in the numerator. You can write down the denominator also. You try to solve this.